Hello, welcome to helpyourmath.com. In this video, we're going to discuss compound interest. Let us look at a situation about compounding. In the last lesson, we looked into interest being calculated, not just on the principal amount, but on interest that had previously been paid as well. With simple interest, we were assuming that we pocketed the interest when we received it. In a standard bank account, any interest we earned is automatically added to our balance, and we earn interest on that interest in future years. This reinvestment of interest is called compounding. In this next video from Investopedia, it will give you an idea of what compound interest is about.
Compound interest is the interest an investor earns on his original investment, plus all the interest earned on the interest that has accumulated over time. It is easier to think of compound interest as interest on interest. To understand compound interest, let's first look at simple interest, the interest earned on the original principal only. Suppose you deposit $10,000 into a high-interest savings account at a 5% simple interest rate for 3 years. The interest you earn each year is 5% times $10,000, which equals $500, for a total of $1,500 of interest at the end of year 3. $500 plus 500 plus 500. Now instead, suppose that you deposit the same $10,000 at 5% interest compounded annually. In year 1, the interest you earn is the same, $500. But in year 2, the interest you earn is 5% times $10,500, the original amount plus the interest you earned in year 1. So the second year's interest is $525. In year 3, you earn 5% interest on $11,025. $10,000 plus 500 year 1 interest plus 525 year 2 interest for an interest payment of $551.25. In total, you earn $1,576.25 in interest over 3 years with compounding interest versus $1,500 with simple interest, a difference of $76.25. The effect of compounding becomes especially powerful over longer time periods as the amount of earned interest becomes larger and larger.
Now let's look at question number 1. Suppose that we deposit $1,000 into a bank account, offering 3% interest compounded monthly. How will our money grow? So let's go to the whiteboard and calculate this out. So in this question, we're asked that we have a deposit, we're given that we have a deposit of $1,000 in the bank, and that we will call our principal. In a bank account, and it's offering 3% interest, and we'll call that our rate. And that's annually. But it's going to be compounded monthly. So per month. How much will our money grow? Well, the 3% interest, as I mentioned, that's our annual percent rate, or APR. Since the interest is being paid monthly, each month we will earn 3%. Divided by 12 for our 12 months in the year. So that's equal to 0.25% per month. Now, what we want to do, we want to take that. So now we can write, we have our principal, which is the same, which is $1,000. Our rate now, we're going to look at it in terms of our monthly rate, is 0.25%. But we have to convert that into a decimal. So we have to take the 0.25% divided by 100%, and that's going to give us 0.0025. So our interest, I, will be equal to our principal times our rate. So that's going to be $1,000 times our rate. And since it's over 1 year, it's one time is 1, or 1 unit. So that's going to be 0.0025, and that's going to be, our interest is going to be $2.50. Accumulated balance is equal to the $1,000, our principal that we started out with, plus the interest that we earned that month, which is our first month, $2.50. So that means that now we have in the bank, starting our second month, we start our second month or finish up our first month with $1,002.50. Now let's try for the second month and see what happens. Well, in the second month, our principal comes from here. Here is our principal. So that's going to be dollars, $1,002.50. Our interest, I, will be principal, $1,002.50, because that's our new principal, times the monthly rate that we calculated earlier, 0.0025, and we get $2.51. And that's rounded, because notice we want to round it to the nearest cent. That's what hundredths are, because our monetary system is divided into cents. That's where it ends. So cents are same thing as hundredths. So our accumulated balance, A, here in our second month now, is $1,002.50 plus our new interest, $2.51. So we add those up and we get this is our new interest. So we get a new total of, after our second month, is $1,002.50. $5.01. So this is how much we will have at the end of our second month. And we can continue this on for this process through many, many months later. Reviewing what we did on the whiteboard, we found, or we were given, the 3% interest as an annual percent rate. So since interest is being paid monthly, each month we will earn 3% divided by 12 for 12 months in the year. That's equal to 0.25% per month. So in our first month, our principal is the $1,000 that we deposit in the bank. The rate, remember, we have to put the rate in a decimal form, so that'll be 0.0025 from our 0.025%. We converted that into a decimal. So our interest, as we found on the whiteboard, is equal to multiplying 1,000 times 0.0025 is equal to $2.50. So our accumulated amount is $1,000 that we put into the account, and the interest, which is $2.50. So we add those up and we get $1,002.50. Now let's look at what happens in our second month. So in our second month, now we have in our bank account $1,002.50. So our new principal becomes $1,002.50. So our interest now is our new principal times that monthly interest, which is 0.0025, as we found earlier. And now we have earned in interest, rounding it, is $2.51. Notice how I round to cents. The nearest hundredth is what we call the cents. So our accumulated balance now becomes A is equal to $1,002.50 from our first month, plus the interest that we earn in our second month, $2.51. So we add that up, and we now have in our second month $1,005.01. Observation. Notice that in the second month, we earned more interest than we did in the first month. This is because we earned interest not only on the original $1,000 we deposited, but we also earned interest on the $250 of interest we earned in the first month. This is the key advantage that compounding of interest gives us. Let us see what happens over a year of compounding. And let us use the following table. So we make a table based on the first 2 months that we just calculated. So we started off with our starting principal, $1,000. We earned $2.50 interest in our first month. So we ended up at the end of the first month, $1,002.50. Now we have $1,002.50, and that's going to be our new starting balance. So we take our new starting balance, we multiply that by 0.25, and now we have the $2.51 interest that we had in question one. And we end up with the $1,002.50 plus $1,002.51, and we add that together, and now we're going to have a new principal for our third month. So we have $1,005.01, and we'll put that for our third month, and that'll be our new starting principal. So we continue this calculation using the fact that we know for a year we have 0.25 to get our new interest. So here we find $1,005.01 times 0.25. Remember rounding, and we again end up with $2.51. And we add that to the $1,005.01, and we end up with a new amount, $1,007.52. So then we have, for our new starting balance in our fourth month, we have $1,007.52. We go through the same type of calculations that we just did, and we end up with the interest as $2.52. And we add that to our starting balance of $1,007.01 plus $2.52 to get $1,010.04. So we take that $1,010.04, go through the same process, and we get $2.53 as our interest. We add that interest to our $1,010.04, and we get $1,012.57. And we continue this again, this process. So finally, after the sixth month, we get $1,015.10. So the $1,015.10 becomes our new starting principal in the seventh month. We continue that calculation, the calculation we have been doing, to end up after our seventh month, $1,017.64. And we continue with the $1,017.64, do our calculation on interest, add it to it, and we get $1,020.18. In our ninth month, we take this $1,020.18. This becomes our starting balance or our new principal. Go through the same calculation. We end up with $2.55 interest, add that in, and we get $1,022.73. We take that $1,022.73 for our 10th month as the starting balance. Continue with our calculation, and we end up with an interest of $2.56. Add this to the $1,022.73, and we end up with $1,025.29. So here we take that $1,025.29, do our calculation to find the interest. We add that interest to that to get $1,027.85. So finally, in our last month, we have $1,027.85. We do our interest calculation, $1,027.85 times 0.25, and that's equal to $2.57. We add that in to our $1,027.85 plus the $2.57 interest that we earned to get $1,030.42. So after 1 year, we end up with that amount using our understanding of compound interest, starting with a yearly amount of 3% and what happens over each month. In question number 3, we want to compound annually over 5 years. Here we will use a 3% annual APR and look for a pattern. So we have here our $1,000 principal plus the interest we earned, because the interest is the principal times the APR here, and it's 1 year. So what we'll do is we'll pull out the $1,000, and this is a simple procedure, and put the bracket, because 1,000 times 1 is 1,000, and 1,000 times 0.03 is the same thing as this. So we can do that. So that's the same thing. When we add these two up, we get 1.03. So now we can say $1,000 our principal times 1.03. And then we calculate that and we get $1,030. In our second year, we do the same process. We start off with the principal that we have, and we multiply it by just that we got from here, same thing, 1.03. And now this year, our second year, times 1.03, because that's our interest in our second year. And we see that these two are the same. So what we can do is we can square them. So now we get, when we put this into our calculator, we get $1,060.90. Similarly, for our third year, $1,000, first year, 1.03, second year, 1.03, and now we're in our third year, we have the 1.03. So we have this done 1, 2, 3 times, so we can have the $1,000, our principal, and then 1.03 to the third power. And we end up with $1,092.73. And we continue on and do it for our fourth year. $1,000, 1.03 first year, 1.03 our second year, 1.03 our third year, and now in our fourth year, 1.03. We have this 1, 2, 3 times this multiplication, so we can put that to the fourth power, and we have $1,000 times 1.03 to the fourth power. And we put that in our calculator, and we get $1,125.51. Now we do for our fifth year. $1,000, our original principal, 1.03 times 1.03 second year times 1.03 third year times 1.04 fourth year, and then finally now our fifth year, 1.03. So we have this 1, 2, 3, 4, 5 times. So we bring that to the fifth power and multiply it by our principal to get $1,159.27. We can continue this process as we see there is a pattern here. And in this case, here's our principal, and we have 1.03 times 1.03 times 1.03, dot, 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 dot. So that can be any number of years, and we'll call T here time. So that means we have here's the principal, and times this that we got from here, times time, and we get $1,000, and we can multiply it by 1.03 to whatever year there is. So we can generalize this into what we'll call a compound interest formula. Notice that $1,000 in the equation was P or P0, the starting amount or principal, as I called it. We found 1.0025 by adding the growth divided by 12, since we compounded 12 times a year. That was in our earlier problem. So our starting value, which was our principal, so it would be times bracket 1 plus the rate, which is the APR, and that is the number of times for the repeated, and this would be the power, okay? It's not multiplication, it's the number of times the multiplication is repeated. It's called the power. So here is what the formula would look like. So A, the accumulated amount, is equal to P, principal, 1 plus our rate over the number of times principal rate, N, the compounded period, and T, the times in the year. The most important thing to remember about using this formula is that it assumes that we put money in the account once and let it sit there earning interest, meaning we're not going to change the amount of the principal. The principal will always remain the same. So here in question number 4, we're going to use the formula that we found for annual compounding. Now, the 5 months we found using table 1. So do we get this? And we're going to see if we get the same or close to the same answers. So we're going to use the calculation that we used in the previous problem. So we're not going to get as deep into the formula. We'll do that in this particular problem. We just want to make the point that the formula does work. So we have $1,000, that's our principal, and we found in question number 2 that the monthly APR was 0.25% or 0.0025. So that would be 1 plus 0.025. So that's why I'm multiplying it by, because 1 plus 0.025 is equal to 1.0025. And that's the reason I'm multiplying my principal times that, since we're doing this based on the monthly APR. And I get, when I plug into my calculator, $1,002.50. Now, if I do this for the second month, I get $1,000. That's my principal again, or what I start out with. And since I'm doing it to the second month, I'll just take this amount, 1.0025, and now I'll put it to the second power. That's our time. And I put it in my calculator, and I get $1,105.01. I do this for the third month. And there, my third month, because that's what my time is, 3 months, $1,000 times 1.0025, and I put this into my calculator, and I get $1,007.52. For my fourth month, similarly, $1,000 times 1.0025 to the fourth power. And I calculate it, and I get $1,010.04. And finally, for my fifth month, I'll get $1,000, 1.0025 to the fifth power, and I'll get $1,000 and $1,012.56. So if I'm just to go back to our earlier question number 2, and we can look back, and we see that the numbers are really, really pretty close. Okay? They're not exact, okay, but they're very, very close. So the formula is very, very useful instead of repeating the same thing over and over and over again. Thank you. I hope that you enjoyed this video. Take care and be well. Bye for now.